Today we're going to be going over how to make a test bench using known testing values. I'm going to be using arrays in order to do this. On the right of the screen is a just basic circuit I've created for testing purposes. It can really be any other kind of circuit, it's just I wanted to create a basic example for this. And on the left is a test bench, which I've already written up, but for speed purposes, but I figured that I will go through it and explain why it's written like this, what the purpose of each line is, and so on. So here I'm just importing my libraries in, pretty standard, and also naming the entity, which should match the file name, so TB in this case, test bench. I've also started here the architecture of the test bench. I've named it behavior, but it can really be anything as long as it's consistent. And the component, which I'm using to test, or the component that I'm testing. So I'm testing the circuit file, the circuit code. So I've listed the component circuit here and its input and output values. I've also created signals here that match the input and output values of the circuit file. I'll explain in detail later why I've done this, but it's essentially to be able to compare the values that I get from the test bench versus the values I got from the circuit file. And I've initialized the inputs. That doesn't need to be done technically, but it's good practice too for testing purposes. If there's errors, it's easier to see where the errors are, so on. And here I created the component binding. It is using the circuit file, and I'm using the data flow architecture right here. You can do multiple of these, so for UUT2, could you be using a different architecture? Let's say it's called DF. In this case, I only have one architecture to test, so I only put one architecture here. This is the start of the creation of the array, so this can be any name, but I've called it signals 1 because that's what we're creating is our first set of signals, A, B, C, D, and F. They don't need to be called the same as the signals in the component, but it just makes things easier, more consistent. I've also created this line here, which explains what the type of the array is. Again, it can be any name as long as it's consistent, but I've called it array testbench1. It shows its range and also the signals that it's using. So we're using signals 1. And in the array, all the signals go in order. So A, B, C, D, F, A, B, C, D, F. A, B, C, and D are values we want to test. You could put many different examples in here. I've just put 5. And F is what we expect out of the circuit file. So I expect if I put in 0, 0, 0, 1 for A, B, C, D, that I will get an output of 1. Here is the instance for each architecture type. It's essentially a port map of the circuit, and we're comparing A and SA, B and SB, C, SB, and so on. And here is the beginning of our process. So this line is a for loop saying that we're going to loop through this test set. So I is which line of the test set we're on. So 1, 2, 3, 4, 5. We're going through its entire range, and we're going to loop through each time. And we're going to make SA be the value in test set 1 at the level we're on. We're going to make it value A. So for the first time we go through the loop, it'll be 0. And if we go through the loop a second time, SA will become 1. Same thing with B, it will first time be 0 and second time be 0, and so on. And then we're going to wait 50 nanoseconds. And this is to avoid errors due to propagation delay. It's important to have a waiting period between. And then we're going to create an assert function, or an assert. And essentially what this does is it outputs in the console an error message if this here is not true. So we're going to compare our test set, which for the first time we go through the loop will be 1, and we'll compare it to the output of the circuit, the actual output, which is SF based on this here, and it will compare and it will check and see if they're the same. And if they are the same, that's great, and it won't output an error, this error, F output error. It will just, it will show that the circuit is working properly and we get the values we expect. And then we wait 50 nanoseconds, and then it goes through the loop again. And again, this is to avoid errors with propagation delay. Then we end the loop, we end the process, and we end the file. So if I run this code, and I pull up the console, I see, well, that's the wave, the waves, which are very important to look at. But just looking at the console, I see that there's an error. It pulls up the assert error and says, oh no, our values in the array don't match what we actually got at this time. And from there we can look at our waves and see where the error is coming from and why it's happening.